This is the Taipei 101 building, a record-breaking building that was built in the Xinyi district in Taiwan. This did have the record for a while of the tallest skyscraper ever built until it was beat by a building in Dubai. And in 2010, if you guys saw the Mission Impossible movie, the latest movie, that one that Tom Cruise is flying off of, yeah, that building's taller. But looking at this one here, what this does boast still is one of the fastest elevators in the world. The top speed that this elevator can reach is 37.7 miles per hour, which may not seem like a whole heck of a lot of speed, but watch it in action here.
いらっしゃいませ。世界最速で8時9分の車でようこそ。Ladies and gentlemen, welcome to Taylor
Visst du det på
This elevator to the Internet Plus Elevator. 前方两侧荧幕显示电梯的楼层高度、速度及时间。両サイドの何かをご覧ください。このエレベーターの高さ、スピードを違います。Please look at the glass monitor.
Ja, ytterst vidare. Ja.
各位贵宾，我们已经抵达89楼，观景台，谢谢。お客様、89階の天。
Okay, so that Taipei 101 elevator, when you watch that video, notice it started at a height of 25 meters, finished at a height, you see it right over there, of 381 meters. And it took, as you see down there at the bottom of the graphic there, it took 36 seconds to do it. So how fast is that, really? If this elevator claims to be the fastest in the world, how fast was this thing really going? You know, it's kind of tough for us to mentally picture that thing because, you know, we don't really deal with meters very often in our part of the globe, even though everybody else does. But how do we quantify that? Well, meters, if you're not quite sure, that's kind of similar to a yard, and you guys have probably seen yardsticks before. So it covered, how many meters did this thing cover in those 36 seconds? How do we figure that out? Yeah, let's go ahead and subtract these two. Let's take 381 meters, let's subtract 25 meters. Yep, so that gives us about exactly 356 meters. So if it did 366 meters in distance over the course of how many seconds? Yeah, it's right down there, 36 seconds. How do we figure out how fast it's going? Yeah, we're just going to go ahead and divide them. Let's take 356 meters and divide it by 36 seconds. You can kind of see it right there. And that's going to give us our meters per second, how fast that actually is going. Which gives us about 9.8 repeating meters per second. Oh, geez, I have no idea how fast that's really going, once again, because we're dealing with meters. So meters per second. What if we change that into miles per hour? So glancing here at the interwebs and typing in their 9.8 and converting it into miles per hour, that's about 22 miles per hour on average. Notice in that video it definitely got pretty fast at one point. But the average speed as we went through there was going to be 22 miles per hour. Let's give you another sense for what this feels like, maybe with a elevator with a view. The CN Tower, which isn't as fast as the that elevator, the Taipei 101. Take a look at this video, and you can get a sense for how fast actually it was going. So you're about ready to see the CN Tower, which by the way is in Canada, in Toronto, Canada. It had about almost the same average speed. It certainly didn't reach the top speed, the record-breaking speed of 37.7 miles per hour. But this is about what the average speed would be like on that Taipei elevator. Notice how fast we're going up. Now, ladies and gentlemen, slope. All slope really is, in the grand scheme of things in real-world applications, it's just a rate of change. As you see, this person's height is definitely changing rather rapidly, more so than most elevators, right? So when it comes time to establishing slope or finding applications with slope, you really don't have to look very far. It can be any change in your, it's any rate of change. Distance covered over time. That's your rate of change. That's the speed. You know, we've heard the formula distance equals rate times time. Well, you're seeing it in action right now as they approach the top of that elevator. So, if slope is nothing more than just a rate of change, let's keep on working with these real world examples and how slope kind of can affect and how we can use slope more in practical terms. So take a look at this problem. A truck driver is at mile marker 624 on Interstate 10. After 3 hours, the driver reached mile marker 432. Just on that information alone, it's possible to calculate their average speed, right? Because that's kind of how those mile markers work. What you need to figure out here first is the distance traveled, and then you can take your distance and divide it by your time, and you can figure out the speed at which this guy was going. So let's go ahead and do that. So if this guy was going 624, mile marker 624, and later he was at mile marker 432, how many miles did he travel? I think what we have to do is subtract these two, right? So minus the 432. Great handwriting here, huh? And then once we get that value, isn't it true that we're just going to take all of that and divide it by the speed, the time it took to do that? So divide that by 3. So what's 624 minus 432? Well, that would be 192 miles. So we're going to take the 192 miles that he traveled, divide it by the 3 hours, and that'll give us our miles per hour, right? We'll call it MI. Don't want to confuse that with meters now, do we? So 192 divided by 3, that'll give us 64 miles per hour. Just throwing that right into a calculator. So 192 divided by 3. Let's take a look at this next example right down here. So Art's cash register contained $150 when he started, opened the store. 8 hours later, his cash register contained $738. So how can we figure out how much money he made that day in sales per hour? I guess the first thing we have to do is figure out how much money he made that day. Remember, and how students goof this problem up is they love to just take the 738 and divide it by 8 to figure out how much money they made. Well, remember, that cash register when he started the day had $150 already in it. So he didn't make that money in that day. So we need to figure out the change that took place here. So we're going to take that 738 and we're going to subtract the 150. So 738 minus 150, that gives us $588. He made that much money in 8 hours. So to figure out how much money they made each hour, divide that result by 8. So that turns out to be $73.50 per hour. Alright, so now it's time to cut you guys loose again. Let's get this assignment wrapped up by doing the final few problems here. There's 3 more there for you which deal with slope. And then after that, then I gave you a couple of review problems there. So go ahead and tackle those review problems as well. Alright, we'll see you guys second hour, I'll see you tomorrow. Third hour, I won't see you until Thursday. So see ya.